Hello learners, on behalf of Indira Gandhi National Open University, we welcome you for this video lecture session. Today's topic is energy resources. This is 33rd module of the course Thermodynamics and its application. I am Shubhashish Maji, professor in School of Engineering and Technology from Indira Gandhi National Open University. Dear learners, let us begin our discussion on the topic energy resources. After listening to this video lecture, you will be able to understand the concept of energy resources. You will be able to know the demand and supply scenario. You will be able to discuss the energy sector in India, and you will also be able to describe the various renewable sources of energy. For most of man's existence on this planet, his only source of energy was the wild food he hunted, gathered and ate. While his invention of machines such as lever, the pulley, the inclined plane, the wedge and the wheel enable him to transmit force applied at one point to another point or in another direction in more useful form, these devices did not increase the total energy at his command. It is only when he brought fire under his control he was able to invent artifacts which enable him to do things he could never do before. Coke, coal and the steam engine powered the industrial revolution, which has resulted in the energy guzzling lifestyles we have today. The principal characteristics of energy resources which have a major impact on decision making in energy matters are as follows: concentration, energy per unit volume or per unit mass for stock type resources, energy flux for flux type resources, quality, fraction of total energy available for conversion to work, and ease of extraction, ease of transport, ease of use, adequacy of supply, material processed per unit of energy extracted. The non-renewable energy resources essentially includes fossil fuel, coal, oil and gas. These were formed over a period of millions of years, and even though they are being formed even today in special geological environment, their rate of formation is so slow that it is practically meaningless in context of human lifespan. Coal is formed from the remains of vegetable matter. Most of the world's coal resources represent accumulation of plant material in swamps. There is a progressive metamorphism of the organic material from passed through lignite and bituminous coal to anthracite. The carbohydrates are first converted into hydrocarbons and then to elemental carbon. Coal is essentially mined by three methods: underground mining, strip or surface mining, and auger mining. Coal is the most abundant commercial energy source in India. Indian coals are largely of bituminous grade, and an estimated 99.5% of indigenous coal resources are in the Gondwana basin. Indian coals usually have a high ash content up to 50%. Ash comprises residual non-combustible matters that comes from silt, clay, silica, etc., which may have contaminated coal at the time of depositions and formation. The sulfur content of Indian coals is usually low, owing to the generally poor and deteriorating quality of Indian coal. Beneficiation processes such as coal washing assume importance. Petroleum and natural gas are often found together and are almost entirely limited to sedimentary rocks and to special geological circumstances. Crude oil consists almost entirely of liquid hydrocarbons with some gaseous hydrocarbons dissolved in them. It is lighter but more viscous than water. Tar and asphalt are semi-solid to solid forms of crude oil. Natural gas consists of hydrocarbons simpler and lighter than those of crude oil, with the most abundant hydrocarbon being methane. Sulfur is an undesirable impurity in both crude oil and natural gas. High sulfur crude oil and natural gas are known as sour crude and sour gas, reflecting the order of hydrogen sulfide, and contain more than 0.5% sulfur by weight. In recent years, India's energy consumption has been increasing at one of the fastest rates in the world due to population growth and economic development. The utility electricity sector in India has one national grid with an installed capacity of 371.977 gigawatt as on 31st July 2020. Renewable power plant constitute 35.94% of total installed capacity. During the fiscal year 2018 and 19, the gross electricity generated by utilities in India was 1,372 terawatt hour, and the total electricity generation, utilities and non-utilities in the country was 1,547 terawatt hour. Here again I would like to mention about the units which we are using for today's discussion. You must know 1 kilowatt is equal to 10 to the power 3 watt, 1 megawatt is equal to 10 to the power 6 watt, 1 gigawatt is equal to 10 to the power 9 watt, 1 terawatt is equal to 10 to the power 12 watt. India's electricity sector is dominated by fossil fuel and in particular coal, which during the 2018-19 fiscal year produced about 3/4 of the country's electricity. Government is making efforts to increase investment in renewable energy. The government's National Electricity Plan of 2018 states that the country does not need additional non-renewable power plant in the utility sector until 2027, with the commissioning of 50,025 megawatt coal-based power plants under construction and addition of 2,75,000 megawatt total installed renewable power capacity after the retirement of nearly 48,000 megawatt coal-fired plants. The installed capacity by source in India as on 31st March 2020 is given as coal 2,05,134.5 megawatt, that comes out to be 55.4% of installed capacity. Large hydro 45,699.32 megawatt, small hydro 4,683.16 megawatt, wind power 37,693.75 megawatt, solar power 34,627.82 megawatt, biomass 10,022.95 megawatt, nuclear power plant 6,780 megawatt, gas 24,955.36 megawatt, and diesel it's only 509.71 megawatt. The roadmap for renewable power by 2022. Total power generation, renewable sources of energy equal to 175 gigawatt, solar energy 100 gigawatt, wind energy 60 gigawatt, small hydro equal to 5 gigawatt, and from other sources of renewable power is equal to 10 gigawatt. The solar energy sector in India offers potentially enormous capacity, though little of it has so far been exploited. The solar radiation of about 5,000 trillion kilowatt hour per year is incident over its landmass, with average daily solar power potential of 0.25 kilowatt hour per meter square of used land area using the available commercially proven technologies. As of 31st March 2020, the installed capacity was 34.63 gigawatt, meeting 9.4% of the utility electricity generation. Some state governments are exploring means to address land availability through innovation. For example, they are exploring means to deploy solar capacity above their extensive irrigation canal projects, thereby harvesting solar energy while reducing the loss of irrigation water by solar evaporation. The state of Gujarat was first to implement the Canal Solar Power Project by using 19,000 km long network of Narmada canals across the state for setting up solar panels to generate electricity. It was the first ever project of its kind in India. So this is the diagram for the solar plants, and you can see the solar panels are there. This diagram is for energy efficient house. There is wind power on roof, there is solar panels for heat and electricity. So these houses are called energy efficient houses and also termed as green buildings. This is the solar electricity generations. The solar panels are there. You can see photovoltaic energy, that is solar energy converted directly to electrical energy. So here you see that solar radiation falls on the photovoltaic cell and there is current passing through the circuit and the bulb is glowing because of the photovoltaic energy. The major disadvantage of solar power, that is PV type only, is that it cannot produce electricity during the night and also during cloudy daytime. In India, this disadvantage can be overcome by installing pumped storage hydroelectricity stations. India has the fourth largest installed wind power capacity in the world. The development of wind power in India began in the 1990s in Tamil Nadu and has significantly increased in the last decade. As of 31st March 2020, the installed capacity of wind power was 37.69 gigawatt spread across many states of India. The largest wind power generating state is Tamil Nadu, accounting for nearly 23% of installed capacity, followed in decreasing order by Gujarat, Maharashtra, Rajasthan and Karnataka. So this diagram shows the wind farms. The wind turbines are placed. You can see the wind farms. There are several wind turbines placed in series or in parallel, and you can also see this wind power if you visit the places, few places in Tamil Nadu. Now this is the coastal development. The wind turbines are placed in the coastal area, and this figure is from Netherlands coastal development. This is another figure, that is the wind turbines that is placed in England's offshore. Biomass is organic matter derived from living or recently living organism. As an energy source, biomass can either be used directly by a combustion to produce heat or indirectly after converting it to various forms of biofuel. Conversion of biomass to biofuel can be achieved by different methods, which are broadly classified into thermal, chemical and biochemical methods. So this is the cycle of biomass energy. Now you can see that we are using our different equipments like chair, table made of wood, and when it is obsolete we just throw it, and that can be used as a biofuel. When the biofuel is used in the power plant, the electricity is generated, and when the biofuel is burned, carbon dioxide is evolved that enters into the atmosphere, and that carbon dioxide is used by the tree for its growth, and that tree again gives us the wood. So this is a cyclic process. We call it cycle of biomass energy. This is the biomass plant for generating electricity, and initially the shredding is there. After that it is burned and use the heat for generating steam in the biomass boiler. That high pressure, high temperature steam passing through the turbine, and turbine is coupled with the shaft of the generator, which produces electricity. Now let us discuss about geothermal power. What is geothermal power? Geothermal power is power generated by geothermal energy. Technologies in use include dry steam power stations, flash steam power stations and binary cycle power stations. Geothermal power stations are similar to other steam turbine thermal power stations. For instance, heat from a fuel source. In geothermal case, the Earth's core is used to heat water or another working fluid. The working fluid is then used to turn a turbine of a generator, thereby producing electricity. The fluid is then cooled and returned to the heat source. So this is the diagram for the geothermal power. If you visit the country like Iceland or New Zealand or Australia, you will find this geothermal sources. Why is geothermal energy considered to be a renewable source of energy? Geothermal power is considered to be a sustainable renewable sources of energy because the heat extraction is small compared with the Earth's heat content. The greenhouse gas emission of geothermal energy stations are on average 45 grams of carbon dioxide per kilowatt hour of electricity, or less than 5% of that of conventional coal-fired plants. So this is the diagram for dry steam power stations. So you can see that the pipe is inserted inside the earth core, where the temperature of water is very high and steam is produced there, and that steam is tapped through the pipe, and here we call it the producing well, where drilling is there for inserting this pipe which extracts steam directly, and that steam is used for the expansion process within the turbine, and the shaft of the turbine is coupled with the shaft of the generator, which in turn produces electricity, and the low pressure low temperature steam coming out from the turbine enters into the condenser. Thereby it is condensed into the water, and that water is again coming into the initial state inside the earth's core. Now this is the diagram for the flash steam power station. So in this case also, the inside the earth core the pressure of water is very high, as well as the temperature also. So the pressure is very high, temperature is very high, and that high temperature and high pressure water, when we tap through the pipe, immediately it converts into steam, because at the outside it is the atmospheric pressure that is much less than the pressure of the water which was there inside the earth's core. So immediately the steam will be generated because of the low atmospheric pressure, and that steam will pass through the turbine, and in turn generator will produce electricity. After that, the low pressure low temperature steam comes out from the turbine, and as usual it will pass through the condenser and converts into liquid water, and that after that the liquid water will enter into the initial state. Now this is another process, we call it binary cycle power stations. Now if the temperature of water which is coming out from the deep core of earth is not so high, in that case we use the binary cycle, where the binary fluid is there, either butane or pentane, whose boiling point is low. So the low temperature water, when it passes through the heat exchanger and the heat is being transferred to the binary fluid, either butane or pentane, and since the boiling point of the binary fluid is less, it will immediately boil after taking heat in the heat exchanger, and the binary fluid will be vaporized state, and it will enter into the turbine, and there will be expansion of the binary fluid in the turbine, and the shaft of the turbine will be coupled with the shaft of the generator which produces electricity, and the low pressure low temperature binary fluid will come out from the turbine, and it will be passing through the condenser. Thereby it will be converting into liquid form, and after that it will again extract heat from the hot fluid which is flowing through the heat exchanger and complete the cycle. Geothermal energy is thermal energy generated and stored in the earth. India's installed capacity of geothermal energy is experimental and commercial use is insignificant. According to some ambitious estimates, India has a potential of 10,600 megawatt in the geothermal provinces, but it still needs to be exploited. India has potential resources to harvest geothermal energy. Let us discuss about the tidal energy. It is also one of the important renewable sources of energy. Tidal power, also called tidal energy, is a form of hydropower that converts the energy obtained from tides into useful forms of power, mainly electricity. Local effects such as shelving, funneling, reflection and resonance can increase the potential of tidal energy in certain regions. This is the diagram for the tidal power plant. You see that how we can generate electricity from the tidal power plant. Now let us discuss about the nuclear power. As of 31st March 2020, India had 6.78 gigawatt of installed nuclear power generation capacity, or nearly 1.8% of total installed utility power generation capacity. India's nuclear power plant development began in 1964. India signed an agreement with General Electric of the United States for the construction and commissioning of two boiling water reactors at Tarapur. In 1967, this effort was placed under India's Department of Atomic Energy. In 1971, India set up its first pressurized heavy water reactor in collaboration with Canada in Rajasthan. In 1987, India created Nuclear Power Corporation of India Limited to commercialize nuclear power. So this is the diagram for the nuclear power plant. You see on the left side there is nuclear reactor where the nuclear fuel is inserted in the nuclear reactor and the nuclear reaction takes place and tremendous heat is generated. That heat is taken by the water and it is converting into high pressure, high temperature steam, and that steam is giving heat to the steam generators, and thereby steam is formed in the steam generators, and that steam is passing through the turbine and in turn producing electricity, and the low pressure, low temperature steam coming out from the turbine passes through the condenser and it is converting into liquid water and it is sent back to the steam generator with the help of pump. Fuel cell. A fuel cell is essentially a battery in which the reactants are continually supplied to the electrode and the products are continually removed. They are much more efficient than heat engines in terms of generating electricity. Most common type of fuel cell are based on hydrogen. Fuel cells are scalable. Large ones can power homes or neighborhood. Small ones can be used in appliances. Distributed generation is a centralized power system consisting of hydrogen generators and fuel cells. This is the diagram of a fuel cell. You see that there are two electrodes. One is anode, second one is cathode. Cathode is going to be positive electrode, anode is negative, and they are separated by a semi-permeable electrolyte, and this semi-permeable electrolyte material will allow to pass the hydrogen ion and not allowing to pass the electrons. Now hydrogen gas is supplied to the electrode anode and thereby forming hydrogen ion and electrons and two hydrogen ion and two electrons is formed from one molecule of hydrogen, and hydrogen ion pass through the electrolytes from anode to cathode, and the electrons will pass through the outer circuit producing electricity, and that's why the bulb will glow. And at the cathode oxygen is supplied, and oxygen plus hydrogen ion plus two electrons forming water, that is H2O. So this is the process for the fuel cell which produces electricity. At the same time they are also producing as a byproduct, that is drinkable water. Now commonly used power plants, as we all know that the commonly used power plants are thermal power plant, nuclear power plant, hydro power plant, gas turbine power plant and combined cycle power plant. And in our earlier lectures we have discussed in detail about the process for thermal power plant, and we had seen that four important components are there for a thermal power plant. One is boiler, second one is turbine, third one is condenser, and the fourth one is the pump. Hydro power plant in India. Water power, like most renewable energy source, is indirect. Solar power and like others such as the wind, it has been contributing to local energy supplies for many centuries. India currently has 197 hydropower plants with above 25 megawatt capacity plus 9 pump storage stations as of 31st March 2020. Total capacity is 47,057 megawatt, and India ranks 5th in the world for potential hydropower capacity. The main source of electric power generations are thermal, hydel and nuclear power plants, but still there are many other non-conventional sources of power available. Those non-conventional sources like wind power, solar power, MHD generation, fuel cell, etc. are becoming the promising alternative sources for electric power generation. Renewable energy sources offer viable option to address the energy security concerns of a country. Today, India has one of the highest potential for the effective use of renewable energy. India is the world's fourth largest producer of wind power after Denmark, Germany and USA. There is a significant potential in India for generations of power from renewable energy sources, small hydro, biomass and solar energy. We have discussed energy resources. Let us very quickly summarize our discussion. We have discussed the concept of energy resources. We have discussed the demand and supply scenario. We have discussed the electricity sector in India, and we have discussed the various renewable sources of energy. Because if we keep on using coal for generating electricity through thermal power plant where coal is being used as a fuel, then there are some difficulties, like it generates pollutants which comes in the atmosphere and there is damage of environment. For sustainable development, we must reduce power generations through thermal power plant where coal is the main sources of fuel. So we must think of alternative sources of energy, and India is planning to generate more power through renewable sources of energy. Thank you very much.